Welcome to Rges Algebra 1, Lesson 10B. This is covering units 5.7 and 5.8. We've been working on factoring. We've been doing this factoring of a trinomial into two binomials. That would be the quadratic trinomials. For the instance, if we had something like this. And we would factor that into two binomials, an x and an x. We're looking for two numbers whose product is 6, 1 and 6, or 2 and 3, but their sum is a -5. And so we would look at that. And hopefully you're getting very comfortable with those now. Now today we've got something that I think is the first idea is a pretty simple idea, and it has to do with what we call the difference of squares, factoring a difference of squares. But I'd like to approach it from the other direction. Let's say I told you to multiply this binomial by this binomial and use FOIL to do it. So if I were using FOIL for my first term, I would get x squared. Remember, this is the first term. This is the middle term, both the combination of the outer and inner terms. And I would get positive 2x minus 2x, or no x's. They cancel out, and for my last term, I would get a -2 times a positive 2, or a -4. Now, notice this pattern. The first terms in both these binomials is the same, and the second term in both binomials is the same. The only difference is one has a negative and one has a positive. And what happens here in my answer when I multiply those and I have no middle term? That's one thing I can say about this. There's no middle term. The second thing I could say is the first term, the x squared, the first term is something squared. And the next thing I could say about this is that the second term, my 4, is something squared. And the last thing I could say about this expression is that it is a subtraction. Now, the answer to a subtraction is called the difference. So now you see where the phrase comes from. The difference, because it's a subtraction of two squares. Because the first term is something squared, and the second term is something squared. So let's just recognize the difference of squares. If I had x squared minus 81, that would be the difference of squares. Because this is something squared, and this is something squared. And we're taking the difference. If I had, x squared minus 36y squared, that's the difference of squares. Why? Because I have something squared, that would be an x squared, a 6y squared, and it's the difference because I'm subtracting them. So recognizing the difference of squares, and once you've recognized it, I would ask, how in the world do I factor it then? And that would go back to where we started. Let's say I had x, hang on, my paper's not standing still, there we go. X squared minus 36. This is the difference of squares, so it would factor to whatever the first term is squared, whatever the second term is squared in both places, but one will be a plus and one will be a minus. Well, I missed the x there. And one will be the minus. Why? Because if I FOILed back again, one more time, I would get x squared, the outer is minus 6x, the inner is plus 6x, and the last is minus 36, which is the same as that. So again, what we say is when I take the product here, the middle terms drop out. That means my O and my I, my outer and my inner. The middle terms drop out because the only thing that's changing is one time I'm adding it and the next time I'm subtracting it. So hopefully that's logical to you. So let's go ahead and do several of these here. If we had a squared minus b squared, that would factor to a plus b times a minus b. If I had x squared minus 49, that would factor to x plus 7 and x minus 7. I could easily have said x minus 7 times x plus 7. I hope you understand that these are reversible. Okay, you might think of why. If I had 4x squared minus 25, this would factor to 2x plus 5, taking whatever I would need to square that, squared to be that, okay, 2x squared, 2x quantity squared, that's what I'm trying to say, is going to be 4x squared. What quantity squared is going to be 25? And that would be 5. Right? So thinking that in your head, I get 2x plus 5, 2x minus 5. What if I have x squared plus 16? That is not the difference of squares. Not the difference. Okay, not the difference of squares. Why? Because I have a plus sign there. In fact, this is prime. This cannot be factored to two binomials. Okay. What if you had 81b squared minus 1? I'm thinking, what times itself, or what squared is going to be 81b squared? Well, it's going to be 9b. So what squared is going to be 1? 1. So I would have 9b plus 1 times 9b minus 1. So again, the whole trick to this chapter is just recognizing, is it the difference of squares? And if it is, it's going to factor to a plus and a minus. Okay. A binomial with a plus and a binomial with a minus. What if I had x squared minus 12? Well, this is x squared, but is this anything squared? No. Okay, so this is prime. Okay, it's not a perfect square. It cannot be factored into two binomials. Okay, I think you have enough there to go ahead and do those problems and check them. Come to class with any questions, but I think that's a pretty straightforward idea. Now let's go to the next concept on 5.8, and that is going to be squaring a binomial. So let's give myself a binomial and let's square it. What would that pattern be? Well, you can already do that. You don't need actually any new knowledge to do that. You would write it out, x minus 5 times x minus 5, and you would FOIL it, x squared minus 5x is minus 10x, minus times a minus is a plus, and 5 times 5 is 25. So you can already do that just by writing it out and then using FOIL. Okay. But let's look at the pattern that develops. Notice this pattern. Go back to the original. Let's take those arrows away and let's think, can I go straight from there to there? Well, you can if you think like this. Square that and you get x squared. Multiply it together, which is negative 5x, and double. So multiply, and let's not do it that way. Okay, multiply and double to get the middle term, and I would get negative 10x, and square the second term and I get, no, square it with the negative sign, okay? A negative times negative is positive, so I would get positive 25. Let's try another one. Let me write several, actually. So you can always do this the long way, but again, what we're trying to teach you now is how to do it by the pattern, by observing the pattern. So we square the first term, x squared, multiply together 3x and double, that would be 6x, and square the last term. And that's all there is to it. Let's try the next one, a binomial. Again, this is a binomial squared. Okay, square the first term, y squared, multiply together and double, that'd be negative 7y doubled, or negative 14y. Double is the same as multiply by 2. And a negative for the last term, negative times negative is positive, and 7 times 7 is 49. Let's do the next one. Square the first term, 3 times 3 is 9, x times x is x squared. For the middle term, multiply together, 3 times 5 is 15, so 15x doubled, or times 2, 15 times 2 is 30x. And positive 5 times positive 5 would be positive 25. And the last one, and again, you're looking at a binomial squared. And how do you find the answer? You could always do it the long way by writing it out, but recognizing the shortcut. You square the first term, 7 times 7 is 49, x times x is x squared. You multiply it together, now it'll be negative. Negative 3 times 7 is 21, negative 21x times 2 is negative 42x. And multiplying, a negative times negative will be positive, and 3 times 3 will be 9. Just as a matter of comment, all of these will have a positive on the third term. Why? Because we're squaring something. And if you'll have a positive over here in the problem, it will be 2 positives, so that'll be a positive. And if you have a negative over here, it'll be 2 negatives, and 2 negatives also create a positive. So that's all there is to this. Just need some practice on your part before they become just very natural to you. And that's we do have maybe a couple of things I'll discuss in class, but for your part, for the homework, just do 1 through 49 odd. Okay, have a good weekend.